Let's look at this problem. It's a word problem. Raj kicks a ball. The flight path of the ball can be modeled by y equals negative x squared minus 4x, where x and y measured in meters. What does x measure? Pretty simple question, but if you think about the way we are teaching our students, was probably something like this. X-intercept when y equals 0, x-coordinate when y equals 3. Pretty meaningless stuff, but this is what we have been doing for quite some time. Now there is a shift. We are asking our students to learn to understand their surrounding world, which sometimes we refer to as common sense. It's not easy. So instead of saying when y equals 0 on the ground, when y equals 3 in flight, 3 meters above ground, and that shift is causing concern among the students, the community, and the teachers. We are surprised by the change. But in reality, this should be understood so that the students can do some real world task. I think that that's where the demands for understanding the context has become so intimate, so important. We got to talk about the connected world now. This connection is very important. Now, the time frame, whether it was introduced quickly or not, I have no idea. But the thing is that this is what we are supposed to do. Now, let's move on to the problem-solving part. And the problem-solving part is the students got to understand the context. This is the ground. This is the flight path, and at some stage it goes to maximum. We are unsure at the beginning. At some stage it takes off from there, goes in a parabolic way, and returns to the ground after traveling certain distance. Now the vector comes in. We are not going to talk about vector. This is the horizontal movement. So x is the horizontal positioning of the ball in course of time. it should be easy, but for some reason in the contemporary classroom the students find it so hard to understand the context. Now the equation is y equals negative x squared minus 4x, and there are two situations. At some stage that ball reaches a height of 3 meters. Now those intersection points are also important. So what we are talking about is two different stages of problem solving. We got to figure out these 2 points, and one other thing, the students have to understand y value, the vertical movement of the ball is 0, x squared minus 4x, and how you solve it, that's well, the nitty-gritty of algebra, which shouldn't be too hard if the student know actually how to expand it properly, and that is supposed to be negative 1. Hopefully at this stage students understand it, so we can simply write it as x squared plus 4x. See, I've done something wrong. It should be x squared minus 4x if I change that sign, so it'll be, that should be equal to 0, and if we factorize, that'll give you x minus 4 equals 0. So x should be, the starting point is 0 and the end point on the ground is 4. So we figured out something. This is 4 meters. Now it's a matter of finding out that distance. So only thing the students have to understand, this is no longer 0. This will be 3 equals negative x squared plus 4x, and then I do a little bit of rearrangement of the equation, which should be easy for the students at this stage, should be. And then factorizing and solving. So x equals 3, x equals 1. So this is supposed to be at a distance of 1 meter. This is supposed to be a distance of 3 meters. Now the students might make an error. That distance, this distance is basically 3 minus 1, which is 2 meters. So now if we go for the proportional reasoning and proportionality, this is 2 out of total number of 4, so that gives you half, which is 50% of the time. It's moving, well, compared to the total movement, which is 4 meters, it's only 50% of the time it is on or above 3 meters. Now I need to check whether the question was well, okay, if the question is on 3 meters or above 3 meters, or the question's answer is going to be a little bit different if we say above 3 meters. So those languages are quite important. I'll stop there.